Hi there, welcome back to this channel. If it's your first time coming to this channel, kindly hit the subscribe button. In this video, we'll be discussing about composite functions, and we have the following functions. So these are the questions we'll be attempting. But first, we have to solve out all the inverses of the function. So we go like f of x equals 3x plus 3. We say let f of x equals y. So since f of x equals y, then y equals 3x plus 3. And we make x the subject of the formula to give us x equals y minus 3 over 3. What I did there was just to take 3 here to give us y minus 3 and then divide both sides by 3 over 3. And we have our answer as x equals y minus 3 over 3. So for the f inverse of x, we have f inverse of x equals x minus 3 over 3. The f inverse of x equals x minus 3 over 3 because x is always the value we are imputing. So instead of writing y here, we write x here. Then our f inverse of x equals x minus 3 over 3. So find our g inverse of x. We also go the same way. G of x equals 2x minus 2. And we also say make g of x equals to y. So since g of x equals to y equals to 2x minus 2. Making x the subject of the formula, we have s equals to y plus 2 over 2. Then our g inverse of x will be x plus 2 over 2. Also, for h inverse of x, we have the same. We are going the same way also. We say let h of x equals y, and recall there we have h of x to be x minus 1. So since h of x equals y, then y equals x minus 1. And making x the subject of the formula, we have x equals to y plus 1. For the last one also, k of x. To get the k inverse of x, we are also going to go the same way. And k of x equals x squared plus 1. We say let k of x equals y. Since k of x equals y, then our y equals x squared plus 1. Making x the subject of the formula, we have x equals root y minus 1. How did I do this? I simply took this one here to give us y minus 1, and I took the square root of both sides. So the square root cancelled the square in this x to give us x, and so we have x equals y minus root y minus 1. And this is all these are the inverses of the functions we have there. So going on to the questions, I like to solve question 1, question 3, question 6, and the last question. So you take the rest as assignment and make sure to submit in the comment section. So starting with question 1 first, we have f of g of h of k. How do we go about it? First, since we know that our k of x equals x squared plus 1, right here, k of x equals to x squared plus 1. And we are going this direction because for each value we get, we are going to impute it into the one before. As in, we are going to input the value of k into h, that of h into g, and g into f. So what will I do it? K of x equals x squared plus 1. So h of k of x will give us what? Recall h of x equals x minus 1. So this k of x will represent x here, and we have x squared plus 1 minus this one here, minus 1. Doing the math, we have x squared plus 1 minus 1. minus 1 takes care of plus 1, and we are left with x squared. That is, our h of k of x equals x squared. So we're also going to plug in the answer of this h of k of x into g. And recall, our g of x is 2x minus 2. So we have g of x equals 2x minus 2. So we are going to plug in this value into x. So we have g of h of k of x to be 2 into bracket x squared minus 2. Doing the math, we have 2x squared minus 2. And this will be our value for the g of h of k of x. Solving further, we are going to plug in the value of this g of h of k of x into f. Since our f of x equals 3x plus 3, then our f of g of h of k of x will be 3 into bracket 2x squared minus 2 plus the 3 here. So we have 6x squared minus 2 plus 3. Solving further, we have 6x squared, minus 6 here, because 3 will multiply minus 2 to give us minus 6. We have 6x squared minus 3. And that's our final answer. So what if we input a number for the value of x? Let's say we use 2. And to get the f of g of h of k of 2, then our answer will be equals 3 into bracket, this is our f of g of h of k of x. So that's what we are going to use here. It will be 6 into bracket 2 squared minus 3. 2 raised to the power 2 is 4, so we have 6 into bracket 4 minus 3. According to the BODMAS rule, we have to multiply first before subtracting. So 6 times 4 gives us 24 minus 3 here. Our answer will be 21. So the f of g of h of k of 2 equals 21. I said earlier that I'll be solving question 1, question 3, question 6, and question 10. So on question 3 now, so I've decided to put all my inverses here to create space for us to solve the rest of the questions. So on question 3 now, we have our function to be g of f of k of h. As I said earlier, we are going to start from this direction. We are going to go from h and we input the value of our h into k, that of k into f, and that of f into g. So as seen here, we see that our h of x is x minus 1. So we write h of x equals to x minus 1. We input the value of this h of x into k of x, giving us k of h of x to be, recall our k of x is x squared plus 1. So it will give us this x minus 1 will represent our x squared here. So we have x minus 1 all squared plus this one. So doing the math, we have x squared minus 1 plus 1 to give us so we'll be squaring this to give us x minus 1 into bracket x minus 1, like the square of x minus 1. So x multiply this to give us x squared, and this one minus x times minus 1 give us minus x, and this one multiply this minus 1 times x to give us x, minus 1 times minus 1 to give us plus 1. So we have s squared minus 2x plus 1 plus this one here. Everything into bracket, I think. So plus this one here. We are going to open bracket to give us x squared minus 2x plus 1 plus 1. Solving for that, we have x squared minus 2x plus 2. So that's the value for our k of h of x. We are going to impute this value into f of x. F of x being 3x plus 3. This value here will represent our 3 here, and so we have 3 into bracket x squared minus 2x plus 2 close bracket plus the 3 here. So opening the bracket now, we have 3x squared minus 6x plus 6 plus the 3 here, giving us 3x squared minus 6x plus 9. So that's the value for our f of k of h of x. So we are going to plug this value into g of x to give us g of x being 2x minus 2. So we are going to plug this value into g of x to give us 2 into bracket 3x squared minus 6x plus 9 close bracket minus the 2 here. So opening the bracket with 2, we have 6x squared minus 12x plus 2 times 9, 18 minus these 2. So we have 6x squared minus 12x plus 18 minus 2 is 16. So these are final value for the g of f of k of h. So these are final expression for the function g of f of k of h of x. So as I said earlier, I said to plug in a number for the value of this x, and we said we are using 2. So using 2 in replacement of this x, we have 6 into bracket 2 squared minus 12 into bracket 2 plus 16. 2 to the power of 2 is 4. 6 times, we have 6 into bracket 4 minus 12 into bracket into 12 times 12 into bracket 2 plus 16. 6 times 4 gives us 24 minus 12 times 4 also gives us 24 plus 16. Plus 24 takes care of minus 24, and we are left with 16. So our g of f of k of h of 2 equals 16. Let's go to the next question. Question 6. It says f inverse of g of h of k. Our k of x, recall, we have our k of x to be x squared plus 1. So we're going to impute our k of x into h of x to give us h of x equals x minus 1. So we are imputing this value in for this x, and so we write it as h of k of x to be x squared plus 1 minus this one. So we have x squared plus 1 minus 1. Minus 1 takes care of plus 1, and so we are left with x squared. So our h of k of x gave us x squared. So we are going to also impute this value of h of k of x into g of x. And we call our g of x there was 2x minus 2. G of x, 2x minus 2. So this x will be representing x here. So we have g of h of k of x to be 2 into bracket x squared minus 2. Solving further, we have 2x squared minus 2. So we're also going to plug this value of g of h of k of x into f inverse. And here we have our f inverse of x as x minus 3 over 3. So our g of h of k of x will now represent our x in the f inverse of x. F inverse of x being x minus 3 over 3. So we are, as I said earlier, we are going to input this value into our x. So we have 2x squared minus 2 all into bracket minus the 3 here over 3. Solving for that, we have 2x squared minus 2 minus 3 over 3, which equals to 2x squared minus 5 over 3. So imputing 2 as the value of our x, we have 2 into bracket 2 to power of 2 minus 5 over 3 to give us 2 into bracket 4 minus 5 over 3. This gave us 2 into bracket 2 to the power of 2 minus 5 over 3. 2 into bracket 4 minus 5 over 3. That's 8 minus 5 over 3, which goes to 3 over 3. 3 here 1, 3 here 1. So our final answer for the f inverse of g of h of k of 2 equals 1. Moving to the last question now, question 10. It says the f inverse of the f inverse of g of h inverse of k. F inverse of g of h inverse of k. Our k of s is x squared. K of s is s squared plus 1. So we are going to input this value into the h inverse of x, which gave us, it's supposed to be x squared. It will be x plus 1 and this y minus x minus 1. That's a mistake. So we're going to input this value into our h inverse of x, which is h inverse of x, which is x plus 1. So the k of us will be our value for x to give us h inverse of k of x equals x squared plus 1 into bracket plus this 1 here. So we have x squared plus 1 plus 1 to give us x squared plus 2. So this is our value for h inverse of k of x. We're also going to plug this value into our g of x. Our g of x there was 2x squared. G of x equals 2x minus 2. So we input this value. We input this as the value of our x here to give us g of h inverse of k of x equals 2 into bracket x squared plus 2 minus this 2 here. Doing the math, we have 2x squared plus 4 minus 2, which will eventually give us 2x squared plus 2. So these are our value for the g of h inverse of k of x. So we're also going to plug in this value into our f inverse of x. And our f inverse of x there was f inverse of x equals x minus 3 over 3. So this value will be plugged in as x here. So we have f inverse of g of h inverse of k of x to be 2x squared plus 2 into bracket minus this 3 here all over 3. So solving for that, we have solving for that, we have 2x squared plus 2 minus 3 over 3. We have 2x squared minus plus 2 minus 3, giving us 2x squared minus 1. Minus 3 plus 3 give us minus 1 over 3. So we are going to plug 2 in as the value of our x. So we say the f inverse of g of h inverse of k of x of 2 equals 2 into bracket 2 to the power of 2 minus 1 over 3. So we have 2 into bracket 4 minus 1. That is 8 minus 1 over 3. We have 7 over 3. And these are final answer for the f inverse of g of h of f inverse of g of h inverse of k of 2. Due to time, I will be solving more than this. As said earlier, do the rest as an assignment and make sure to specify it, the ones you've done, under the comment section. Make sure to subscribe and keep learning. Bye.